Welcome back to The Explainer. So glad you're here. Today, we're diving into a really specialized, kind of misunderstood Python data type. We're talking about locking down your data. When your regular sets absolutely positively must be frozen solid so no one can mess with them, we pull out a pretty awesome tool, the FrozenSet.
Let me ask you this. You're in the zone coding away, and you decide, hey, I'll just use a regular set as a dictionary key, right? It seems logical. You hit run and, bam, you get hit with that incredibly frustrating type error, unhashable type set. It just totally breaks your script, kills your momentum, super annoying. But what if I told you Python actually has a built-in solution explicitly designed to cure this exact headache?
Okay, let's dive right into this. To really wrap our heads around it, I want you to anchor everything today on this one and powerful analogy. A FrozenSet is to a set exactly what a tuple is to a list. It's the immutable, hashable version. That's the golden rule here. If you've ever used a tuple because you needed a sequence to be strictly hands-off after you made it, well, you already intuitively get the FrozenSet.
But wait, why did Python throw that error at us earlier? Why reject our perfectly good set? Well, it all boils down to hashability. For an object to be hashable in Python, its internal state just cannot change, ever. Think of a hash like a permanent fingerprint. If a regular set can grow or shrink, its fingerprint keeps shifting around. Python just flat out doesn't trust it as a dictionary key because it might lose track of it. But frozen sets, they're locked, immutable. Python trusts that their fingerprint will never change, making them totally safe and perfectly viable to use as dict keys.
Now, what's really interesting here is looking at them side by side. Are regular sets mutable? Yup. Frozen sets? No way. Hashable? Regular sets are a no, so no dict keys for them. Frozen sets? Yes, absolutely ready for dict keys. You can easily use .add or .remove on a regular set, but try that on a frozen set and you'll get an immediate attribute error. But here's the cool part. Both of them fully support your standard set operations, like unions and intersections. Oh, and crucially, you can't put a regular set inside another set, but a frozen set, you absolutely can. Let's actually look at the code. Bringing these into existence is super simple. You just pass an iterable right into the frozen set constructor. That's it. And those read-only math operations we just talked about, they work flawlessly. If you take a fixed frozen set and run an intersection or union against another set, it just calculates it and spits out a brand new frozen set. But the real magic is when you look at building a dictionary. We can literally use frozen sets of spices, like cardamom and ginger, as the actual dictionary keys to look up the string masala chai. A regular set literally cannot do this. We're also cleanly nesting two frozen sets inside another set right alongside it. And this perfectly shows what happens when we try to break the rules. If you try to mutate a frozen set after it's made, say by calling .add on it, Python instantly shuts it down. Boom, attribute error. It explicitly tells you the object has no attribute add. Remember, this isn't a bug, this is the core feature. That data is locked down tight. So let's look at the classic anti-pattern versus the fix. The mistake is mapping a regular mutable set as a key, which triggers that dreaded type error about an unhashable type we saw earlier. The elegant fix? Just convert it first. Wrap it in FrozenSet. Literally one simple line of code, and your structure goes from totally broken to perfectly functional, a real game changer. Beyond just dictionary keys, when should you actually use a frozen set in the real world? Well, you use it when you need an ironclad guarantee that a set is never accidentally modified by some other part of your code. It's great for protecting function arguments so they stay pristine. It's also fantastic for locking in valid configuration values, think like an approved list of currencies, USD, Euro, INR. And of course, it's the standard if you need to store sets inside other sets. Let's move to a quick rapid-fire review to really cement all this. Question 1. What is the absolute key difference between a regular set and a frozen set? Immutability. The frozen set is completely locked. Once you make it, that's it. No adding, no removing, no updating. It is literally frozen. Question 2. Why would you specifically need to use a frozen set as a dictionary key? Because it is fundamentally hashable. Its immutability guarantees a stable hash value. A regular set can change, which makes it unhashable and completely useless as a dictionary key. Next up, question 3. Since it's locked in frozen, can a frozen set still support math operations like unions? Absolutely, yes. All your read-only set operations, union, intersection, difference, they all work perfectly. You just get a brand new frozen set returned to you, leaving the original completely untouched. Question 4. How exactly do you create a frozen set out of an existing list?
It's just a single function call. Pass any iterable, a list, a tuple, whatever, straight into the FrozenSet constructor, and it locks it down. Easy as that. Let's see how strict this really is. Question 5. Can a frozen set contain mutable elements inside of it? No way. It is strict all the way down. Every single element inside a frozen set must also be hashable and immutable. You definitely cannot sneak a regular list or set in there. And finally, bringing us full circle, question 6. What's the key analogy to help us remember this whole thing? So the crucial takeaway here is, a frozen set is to a set exactly what a tuple is to a list. It's the immutable, hashable version. Keep that analogy locked in. And remember, they're both incredibly memory-efficient ways to secure your fixed data.
And that wraps up our explainer. It's pretty wild how one simple data type solves such massive structural problems in Python. So I'll leave you with this. Next time you sit down to write a script, take a hard look at your data structures. Are you leaving your data vulnerable to accidental changes? Or is it time for you to finally freeze your sets? Thanks for joining me today, and I'll catch you in the next explainer.